So that's synthesis, two or more substances combining to form a compound. The general form that we show reactions in is just with letters. So for synthesis, we go A plus B goes to AB. So just like what we saw with our sodium plus chlorine equals sodium chloride, this is the general form of all synthesis reactions. There's only one product in these. Okay, it can be really helpful to think about chemical reactions like relationships or like people combining. So you've got one person and another person, and then they get together and they become a couple. That is a synthesis reaction, and that might be an easy way to remember it. Okay. Here's a couple examples. So hydrogen and chlorine make hydrochloric acid or hydrogen chloride. Iron and oxygen make iron 2 oxide. So to help predict states, gases plus gases will make a gas. So in this one, you can see I've got a gas, and it makes a gas. And then if you've got a solid plus a gas, this is like what we saw with the salt there. We had sodium in a solid form, chlorine in gas form, and it made a solid salt. So what you're looking for, 2 elements on the reactant side. 2 elements as reactants. And then this might be kind of review so far. One thing that you likely didn't do in grade 10 was predicting products. So that might be something new. So predicting the products, we assume that the product is a compound made of those 2 elements joined together, and that compound is made up of ions. So what you're going to do is just use the most common charge for each ion. So magnesium, let's get out a periodic table actually. So magnesium is in the second row here. So Mg is going to be 2 plus, right? Oh, actually, you know what? I'm going to write this out a little differently. Sorry. So reaction of magnesium and iodine, I'm just going to write this out like Mg plus I. And then it's going to go to, and we're going to combine Mg and I. We do need to make sure that we're using charges and combining these appropriately though. So I'm going to just write out here, magnesium has a charge of 2 plus. Iodine is in this row here, so it's -1 when it forms an ion. So when we cross these over and swap them, the iodine is going to get a 2 by it. So MgI2. And I did not give you the state of these, but I'm just going to. We're going to call magnesium a solid and iodine a gas. So what would my product be? Solid or gas? Solid. Yeah. Awesome. Okay. So that is synthesis. Decomposition is very similar. It is one substance breaking down, so it's just basically the opposite, to form 2 or more simpler substances. So the general form of this reaction is AB goes to A plus B, opposite of synthesis. In synthesis, we had only one product, in decomposition, we have only one reactant. So another time you might see this is if you have hydrogen peroxide at home, it expires over a certain amount of time, and that's because it turns into water and oxygen gas. So when you see one reactant and then two products, decomposition is occurring. So that's one example. And again, if we think about this like relationships between people, you've got a couple and then they're splitting up and they're separated at the end. An example of this, silver oxide plus heat, and sometimes we will see like energy being added to reactions. So silver oxide plus heat breaks down into silver and oxygen. Calcium carbonate breaks down into calcium oxide and carbon monoxide gas. These states are found from the periodic table. Some states you need to actually figure out experimentally, but a metal oxide is always a solid. So a metal with an oxygen is always a solid. So calcium is a metal, oxygen solid. And then if we're looking at our non-metals, so on the table that you guys have on the front page of this, oh, this isn't in color. Okay, I'm gonna give you guys some colors later, and we're gonna color in the periodic table a little bit, but you can kind of see things that are generally gases on their own are like a very light color on here. And then the liquids and solids are really hard to distinguish on this, but here we go. So bromine and mercury are going to be in liquid form when they're by themselves. All of these light colored yellow ones are going to be in a gas when they're by themselves, and then the rest of them are all going to be solid. So I will put this up and put colors out, and you guys can color on them later if you want to. Okay. So what to look for? We're looking for a single compound on the reactant side, and then you're going to be like, that's a decomposition reaction. Good stuff. You're predicting the products by going, okay, this compound is just going to break into the elements which make it up. So silver oxide is just breaking down into silver and oxygen. Calcium carbonate is just breaking down into calcium oxide and carbon monoxide. Okay, water can be decomposed by electricity, so this is called electrolysis. So H2O2, whoops, nope, that's not what water is. H2O, when it's in a gas form, so we put this into a gas form, and then we put electricity through it, and what we get is hydrogen and oxygen gas. We do need to balance this equation. So 2 goes there, 2 goes there. Those guys are both gases. Yeah. And those are kind of the two most simple ones. Let me just have a look at the questions that are in the textbook. See if we want to go over combustion. Have we done elephant toothpaste before? We have? Okay. $65 to $67. Okay, now we're going to go through a couple more and then we'll do some questions. All right. So combustion reactions. In a combustion reaction, a substance is reacting with oxygen from the atmosphere. So it's essentially burning, and we see a lot of energy being given off in the form of heat or light. Generally, what we're going to see combustion reactions with is things called hydrocarbons. So they're just compounds that contain carbon and hydrogen, and they're just highly reactive with oxygen. So general reaction is going to be C and then X for some amount of the carbon, H and then a little Y. So that's just the subscript. It's like there's some amount. Goes to, or plus O2 goes to, and then our products of combustion are always carbon dioxide and water. So anytime we have a combustion reaction, we're seeing carbon dioxide and water as our products. So to look for a hydrocarbon reactant, and CO2 and H2O as a product. So in order to predict the products, you're adding oxygen gas to the hydrocarbon. So you might just be given a hydrocarbon. So you're going to add oxygen gas to it, and then you're going to write the products as CO2 and H2O liquid. And that's always going to be our products for these. So for example, we might be asked for the combustion reaction of liquid hexane. So you're going to go C6H14, and this is liquid. So I'm going to put a little L here, plus oxygen gas, combusts, a lot of heat or light is given off, and I've got carbon dioxide gas and and H2O gas. Sorry, I was trying to balance it. And H2O gas as our products. Okay, if we balance this, I'm not going to make you guys balance this right now. I'm just going to give you the balanced equation. But just make sure that you are going through and balancing and not just leaving things like this. You would get this. Now, water is going to be in gas form when we have got a product from this. So in a combustion reaction, water is given off as a vapor. So it is a gas. Anywhere else that we see water in equation, it's generally going to be a liquid. But in the case of hydrocarbon combustions, we do see a gas, water vapor being given off. Okay, and then there is another kind of special little type of hydrocarbon. Some hydrocarbons contain sulfur. so S, and they will also produce SO2 in addition to the water and the carbon dioxide. So for example, here's a hydrocarbon that contains sulfur. It reacts with oxygen and it makes carbon dioxide, water, and SO2. So just note, if your hydrocarbon has a sulfur in it, you are going to see that. Sulfur dioxide reacts with water to form sulfurous acid. Which is actually a major component of acid rain. So this is that process here. So sulfur dioxide, which is a gas and can be found in the atmosphere sometimes. If it reacts with water, it creates sulfurous acid. And then, have you guys heard of acid rain? That was a pretty big problem when I was a kid. It was really talked about a lot. Kind of the way that we talk about climate change now, we talked about acid rain when I was a kid. And it has been, we're on a pretty good trend in many places, but acid rain does still affect a lot of places. It's interesting. Okay, so that's combustion reaction. Generally, compounds are dissolved in water to make a solution. So therefore, they're in that state that we call aqueous. Did I spell that right? No, I did not. Oh, yeah, I did. Yeah, definitely. Sorry about that. Aqueous state, they are more likely to react in solution form. So when you've got something in solution, like if you've got salt in a water solution versus a pile of salt, that salt that's in a water solution is aqueous, and the molecules are spread out quite a bit more, and they're just able to react better than like a pile of solid salt. So because the particles are spread out, and they're also moving faster. So we know that when things are in solid form, they are quite close together, and those molecules aren't moving around very much. Chemical reactions are all about atoms just like colliding with each other at the right geometry or the right angles. So the faster things are moving and the more spread out they are, well, too spread out doesn't really work very well, but generally as a rule, if their atoms are more spread out and if they're moving faster, we're going to see faster reactions. Cool. So in the ones that we've seen so far, in our decomposition, our synthesis, and our combustion reactions, we're seeing gases given off, not all the time, but sometimes. In the next couple, single replacement, double replacement, and neutralization, we will not be seeing gases given off. So let's see here. What I'm going to get you guys to do, we're going to move on to the other reactions, the single, double, and neutralization reactions tomorrow. But for tonight, or right now, if we can do it, page 118, questions, 67E, G, K, and P. Okay, if you guys can just do those for the next, I guess about like 5 minutes left. We'll move on to the other reaction types tomorrow, and then the lab that we're setting up for is actually seeing some of these reactions in process, which is pretty cool. Yeah. Oh, and I'll put up that colored version of the chart so that you guys can color yours in a little bit if you'd like to, because that would be helpful information to have. So I would just maybe suggest adding this to your actual periodic table that you have currently. I also have highlighters if you guys would prefer highlighting. I don't know how old you are. Wow. Solid day.